Okay, wanted to cover part 2 of 11.2, simplifying radicals. This covers the product property of radicals. Now, a lot of times when I give you a square root, it won't be simplified, or it won't come out as a whole number. So in an effort to not have something that is a crazy non-terminating decimal, we will use what we call as simplifying radicals. So, the square root of two numbers being multiplied together can be broken up as two separate radicals and vice versa. If they're two separate ones, we can treat it as basically one whole number underneath a radical. So for example, if I'm using this calculator, I already typed this in here, but if I have the square root of 32, which can be this 5 point blah 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 number, there's mathematically a cleaner way to represent what that is by simplifying the radical, which is kind of what this section's about. All right, so going back, you have some of the skills to be able to do this already. The main thing is writing out the prime factorization of the number that's inside the radical. And once you do that, we look for pairs of numbers to take out. So for example, we know that the square root of 4 equals 2. Well, if I break down a 4, it's 2 times 2. So this is what I mean by pairs. So when we break down our prime factorization, look for pairs of numbers to come out as one whole number. So that's essentially what we're going to do. If there's multiple pairs of numbers that come out, we would just multiply those together at the end to get our final answer. So let's take a look at some of these examples. The square root of 50 I kind of broke down here. So we have 2 times 5 times 5 after we break it down. And as you can see, my pair of numbers that are in here is pair of 5, so that 5 would come out, and I would rewrite it as 5 root 2. As for 48, we look at how we break it down. So 2 and 24, you're just doing your factor tree, 2 and 12, 2 and 6, 2 and 3. So then you can rewrite these, and as you get more comfortable, you'll just be like, oh, here's a pair of 2s and here's a pair of 2s. But I wrote it out here. So the square root of 48 is all of these prime numbers multiplied together. We have a pair of 2s here and a pair of 2s here, so each one of those pairs come out. And then we multiply those together to give us 4. Sometimes there's going to be other numbers underneath the radical that would still be there, and you'd multiply those together as well to include that in your final answer. So the square root of 48 simplifies to 4 times the square root of 3. Here's a checkpoint, so go ahead and pause the video here, see if you can figure these out. If not, do a couple with me, and then pause the video and try to do them on your own and check your answers. So 12, we're going to break that down to 2 and 6. 6 breaks down to 2 and 3. So if you notice, this would be written as the square root of 2 times 2 times 3. We have a pair of 2's, which would come out because 2 times 2 is 4. The square root of 4 is 2. So this would be 2 root 3 as our final answer there. All right, so now we're going to break down 32. So 32 we can divide. Remember, even numbers we can divide by 2. So I'm going to break out the calculator and just go through this a long way. So 32 divided by 2, that gives us 16. So we have 2 and 16. We can break this down, 2. And if it's already in here, I can just do divide by 2 again. Boom, 2 and 8. Divide that by 2, because it's an even number. 2 and 4. And we know 4 is 2 and 2. So instead of rewriting all these underneath the radical, I'm looking for pairs. So I have a pair of 2's, so 1, 2 will come out. Another pair of 2's, so that 2 will come out. So I have basically 2 times 2 on the outside. Then I have that 2 left over, that stays underneath the radical. 2 times 2 is 4, and then root 2 would be my final answer. For these examples, just like we said at the beginning, these can basically be written underneath the same radical. So even though they're separated, we can still treat them the same way. I'm going to break these down. So this is going to be a 2 and a 10, because 20 divided by 2 is 10. Break down the 10, it's an even number, 2 and 5. Those are all prime numbers there. I'm going to break down my 40. I'll go ahead and switch colors here. So I have 2 and 20. I can break down 20, 2 and 10, and then 2 and 5. So if we look at all of our numbers here in our prime factorization, I have 1, 2, 3, 4, 5 2's. So I'm going to write those down. 1, 2, 3, 4, 5 2's, and then I have 2 5s. Those are essentially are all underneath the radical. So I'm looking for my pairs of numbers. I have a pair of 2s, I have another pair, and I have a pair of 5s. So I can bring out those. So I have 2 2s and a 5, and then what's left over is this lonely 2 right here. So this would be 2 times 2, which would be 4, times 5, which would be 20. So this would be 20 root 2 as my final answer. All right, over here, same idea. We have 18 and 10, so we can break that. 2 and 9, 3 and 3, 2 and 5. From here, if you want to look, I have a pair of 2s, so that comes out. I have a pair of 3s, that comes out. Then I have that 5 left over, so that stays within the radical. 2 times 3 is 6, root 5. All right, on the next page of notes, we talk about simplifying a radical expression. Like sometimes there might be a number that starts out there already, or they add variables to this type of problem. The variables are listed the same way. You can just write out however many there are, and we're still looking for pairs because these are all square roots. So if I break down 44, 44 breaks down to 2 and 22, 2 and 11. That's how I got, my 2, 2 and 11. I have 5 x's, 1, 2, 3, 4, 5. So this is the prime factorization of 44x to the 5th. All right, so now when you look for your pairs, you can see we have a pair of 2s here. We have a pair of x's. We have another pair of x's. So that's how I get my 2 to come out. There's that 2, and here's one pair of x's and another pair of x's. So you're still looking for those pairs to come out of the problem. Once I do that, what's left over? I have an 11 and an x, so that stays within the radical. Then you multiply them together, 3 times 2, that's where I get my 6, x times x, that's how I get my x squared, and I have that final answer. So let's go ahead and try these checkpoints. Go ahead and based on that previous example, pause it, see if you can do it yourself. If not, watch a couple of these and then pause them between each problem to see if you can do them independently. So this first example, we have 27. We do not have 2. 2 won't work, so I'm going to try 3, right? 27 divided by 3 would be the next number that I try. So 27 divided by 3, 3 and 9, so 3 and 9. And then 9 is, 9 divided by 3 is 3, so 9 breaks down to 3 and 3. So my prime factorization of this would be 3 3s, and then n squared, right like that. So now I'm looking for my pairs. Well, I have a pair of 3s, so that 3 comes out. I have a pair of n's, so that n comes out. And whatever does not have a pair stays within the radical. In this case, it would be 3. So my answer would be 3n root 3. All right, the next example, don't worry about this negative. This negative is going to be in the final answer, but we do have a that is outside, and we're going to break down 60, and then we have 7 a's in there as well. So let's go ahead and break down 60. I always like to start with 2 when it's an even number. So 60 divided by 2 gives us 30, so 2 and 30. You can still break down 30 since it's already in there. Divide that by 2. So now we have 2 and 15. 15, if you know it's 3 and 5, but if not, you can divide again by 3 to see that it's 3 and 5. And then we have 7 a's. Ugh, what a mess. But we can see here that I have a pair of 2's that's going to come out. I have this a already, so I have that a. I bring my pair of 2's out. There's my 1, 2. I got a negative out front. Let me draw this here because these problems are separated. Then I also have the 3 and the 5 that's going to stay inside of the radical, right? So I'm going to have that 15 remaining, but I also have 7 a's. So 1, 2, 3, 4, 5, 6, 7. So the question is, how many of these are actually going to come out? We'll look for pairs. Here's one pair, two pairs, three pairs. So I have three A's that are going to come out of that. And then what remains is going to be the 3 times 5, which is 15, and then that one A left over. So when I rewrite this, I'm going to have that negative stay in there. So I have a negative, and I'll put the 2 right there. Then I have 1, 2, 3, 4 A's. So A to the 4th, and then square root, and then whatever was left over was that 15A. So that would be the final answer for that one. Right over here, we don't have numbers, which actually makes it easier. We just have the variables. So we're looking for pairs of variables. So if I rewrite this without the exponents, I have an x, and I have 5 y's. 1, 2, 3, 4, 5. I think as you get comfortable with this, you'll start to see patterns and where you can take shortcuts, but just doing it all the long way to start. So we're looking for our pairs that can come out of the radical. So I have an x that comes out. I have a y here because there's 2 y's, so that's 1 y that comes out. I have another pair of y's, so that comes out. And then what's left over is just the 1 y. So we can rewrite this as x and then y squared square root y as my final simplified version of that radical.